right, guys, so the second day on graphing from Vertex form, and we're going to look at a couple of equations here that actually look a little bit different, but we're going to use the same process that we learned yesterday, just looking for those transformations. You know, where's the vertex? Is it opening up or down? And then finding the zeros if it has them, or y-intercept if it doesn't, right? So here's our first one. So hopefully you're taking a look at it and really thinking about it. Now, this one looks strange. And the question probably is this actually in vertex form? I don't see any parentheses there, so I'm not sure if it really is in vertex form. But hopefully you're kind of thinking about your transformations and saying, okay, well, if it's a -8 at the end, that means that it's moving down 8, right? That's what that would mean. The -8 would mean that it's a translation down 8. And if there's no parentheses, that means it didn't move at all left or right. So the fact that this is just an x squared is really the same thing as saying x minus 0 squared, right? I don't have to write a 0. It means the same thing. So that means it's moving 0 left and right and down 8. So yeah, I can still find my vertex, and technically this is still in standard form even though there's no parentheses there. So my vertex would be 0 left and right, down 8 would mean -8. And then just like before, I look at that a value. So since a is 2, that's greater than 0. So that means I'm opening up. So if I get my vertex on the graph here at 0 left and right and down 8, and it's opening up, then I will definitely have zeros, right? It's going to cross the x-axis. So then I just do my work, just like we talked about yesterday for finding the zeros. Plug in y equals 0 in order to do that. So I have 2x squared minus 8 equals 0. Add 8 to both sides. Divide by 2. X squared equals 4, so I get square root both sides. And remember, when you take the square root, we should have two answers, 2 and -2. And we always write our zeros as points, 2, 0, and -2, 0. So I can plot those on my graph just like we talked about yesterday. And then I've got my parabola, and I can just graph away, make that U shape as good as we possibly can, right? All right, so now take a look at this one and see if you guys can actually do this one on your own. Same idea here, right? This is actually in standard form. Or excuse me, vertex form. This is actually in vertex form. Think about, where is your vertex? Is it opening up or down? Will there be zeros? So I see here, this means that it's moving down 2, right? This would be like x minus 0 squared, so it's moving 0 left and right. So my vertex should be at the point 0, -2. Since a is 1/2, 1/2 is greater than 0, so it's opening up. And if it's opening up at that point, there will definitely be zeros. So then I'm just going to go ahead and find my zeros. So I have 1/2 x squared minus 2 equals 0. I'm going to add 2 to both sides to start with, although you could have started with clearing your fraction. So you could either add 2 to both sides first or clear your fraction first. Hopefully you remember how you clear a fraction. We multiply by the denominator, right? We never divide by a fraction. We multiply by the denominator. So I have x squared equals 4, and then I take the square root. And look at that, I end up with the same thing. X equals 2 and -2. And so my zeros are 2, 0, and -2, 0, written as points. So there are my 2 zeros. And then I can graph my parabola after that. So hopefully nothing is seeming too crazy today, just a little bit doing the same kind of thing, just ones that maybe didn't look exactly like we did yesterday, but it's still in vertex form, we can still do it. I got one last one. This one is meant for you guys to do. This is really just a recap of yesterday, what we talked about. So go ahead and see if you guys can do this one. So I see on this one, if I have plus 3 on the inside, that means that I'm moving left 3. So my vertex would be at negative 3, and up 5 would be positive 5, right? Negative 3, 5 would be my vertex. Negative 3, 5. A is 1/3. So since A is greater than 0, it is opening up. Oh, hang on. That means if I have a parabola opening up and it's already above the x-axis, I am not going to have any zeros. So you could save yourself some time and effort and know that if it's opening up and the vertex is way up here already, that means that there's going to be no zeros, right? We talked about that yesterday of taking a look at it. So if there's no zeros, if I did all the work to find the zeros, you'd end up with a no solution, right? So instead, what I need to do is I need to find the y-intercept, because that's the easiest point that I could plug in. So I'm going to plug in x equals 0. So let's see, y equals 1/3 times 0 plus 3 squared plus 5. Let's see now, the 0 doesn't just disappear. What is 0 plus 3? Okay, it's 3. So 3 squared, so I have y equals 1/3 times 9 plus 5. Multiply before we add. 1/3 of 9 is 3. 3 plus 5, y equals 8. So my y-intercept, is the point 0, 8. So there's my y-intercept. And then I want to write down my axis of symmetry, right? Where is that axis of symmetry? Here it is right here. My axis of symmetry would be the line x equals negative 3. X equals negative 3 is my line of symmetry. And so that means I can just plot another point by hopping right over it. This one was 1, 2, 3 to the right. So I'm going to go 1, 2, 3 to the left. And there's my next point. That point would be at negative 6, 8, if you couldn't see it very well. And then I have all the points I need, and I can go ahead and graph my parabola. So I just wanted to do one more with you where you didn't have zeros so you can remember the process, but hopefully after yesterday you were pretty solid on that. Nothing new there. And then just looking at a couple here that are actually in vertex form that look a little bit different. So remember, if there's no parentheses, it just means they're not moving anywhere left or right. So that would be a 0 left or right. All right, guys, you got this.